Hello, good morning, everyone. Welcome to the session on geniuschalk. In this session, I will be discussing HCF and LCM. Second part. In the first part, we have discussed first few 10 questions, 11 questions. Now, let's discuss the next part. So, let's start the session. Okay, so there we have the first question. It says the HCF of 24721284 and a third number n is 12. And if their LCM is this one, then the number n is what? Yesterday we have discussed one thing, that HCF and LCM of two numbers is always equal to the product of them. Let's take, just for example, if I take 12 and 16, I take two numbers and what is the HCF of both? We know that HCF is the highest common factor. So 4 is a number which is present in both. We can see 4 is present in both. So 4 is the HCF. What is the LCM? For LCM, I have told you, read the table of the highest number, or you can just find the powers, like 4 is present in both. 4. So this 4 is common, and this 3 and this 4. So this is 12 fours are 48. This is the LCM. Or read the table. If the numbers are small, read the table of the least number, highest number, and stop at that where the other number also cancel. Like 16 ones are 16, 12 does not cancel 16. Then 16 twos are 32, 12 does not cancel 32. 16 threes are 48, 12 cancel 48. So 48 would be my LCM. That means I can write HCF into LCM. If you find the product in both these cases, you will find an interesting thing, that this is going to be 192, the product, and this also is 16 to the 32, 16 plus 3, 19. You can see both the products are equal. That means this formula is always proven for all numbers whose product is taken and HCF LCM is taken. So the same formula I have to apply in this question. Why so? Because in this question also we can see that this part is given. You see HCF is given as 12, and afterwards LCM is also given as this. HCF and LCM is given, and there are three numbers. So this theory is not only valid for two numbers, it is also valid for three number or four number, right? It's not only valid for two numbers, it can be three numbers also, it can be four numbers also. The only thing is that overall we have to take the HCF and the LCM, right? So in this case, let's say, for example, you want to prove it for three numbers. Let's say one number you have taken 4, another number you have taken 3, another number you have taken 5. So what is the product? 12 5s are 60. Now what is the HCF of both, or all the three? Not both. HCF is 1 because nothing is common. And what is the LCM? LCM is again all are co-prime, so LCM is also 60. So you can see again the same theory prevails. Okay, so let's apply HCF and LCM. It must be equal to the product of all the three numbers. If any number is unknown, we can find it, right? So this is the theory which we have to apply in this question, right? So let's apply 2472. We have 2472. We have 1284, and we have another number n, and their HCF is 12, and LCM is 2 to the power 3, 3 to the power 2, 5, and 103, as well as 107. Now, conceptually, what we will do is that these two things will be going in the denominator. So I can write 2 to the power 3, 3 to the power 2, 5, then 103, and 107. And this all will be in the denominator. Yeah. And here also I have 12 also, right? Which was the HCF. HCF was 12. This overall is the LCM plus this one as well. Now, if this goes in division, this will be like 2472. Can I write it like, because it is divisible by 12, so 12 into 2 twos are 4, 24. 12 twos are 24, sorry, and 0, and 12 6 are 72. Similarly, this also cancels by 20, 12, 12 ones are 12, and 12 sevens are 84. Now you can see this is all equal to n. We can just cancel it. 107 is cancelled. Then you can see 103 twos are 206. Now 12 is cancelled by 12. This 2 is cancelled by 1 power of 2. Then I'm left with 12. So this is 4. See, this is 4. This is, yeah, this is, you see, this can be written as 4, 2 square, and I take 1, 3. And afterwards, what I'll do is, because I need to just solve it, right? I can solve it like this also. You see, this is 4. Out of these 2, 3, I can take 1, 3. So this is 3 into 5 divided by 12. So this is 12 cancel. What is left? 3 into 5. So the right answer of the question is none of these, as 3 into 5 is my left thing, and that should be my answer, right? So this is the approach we have to apply for this question. It's a good one. Next. So yesterday we have discussed the concept of HCF for fraction. Now we will discuss the concept of LCM for fraction. These are all 2.5. I can write them in 25 by 10. 0.5, I can write this decimal goes, and 175 point. So I can take 30. So please note this, that whenever we have been asked about the LCM or the HCF of fractions, then write the rule that LCM of fraction, let's say A by B, C by D, or E by F. Suppose this is asked, then the answer is always equals to LCM of all the numerators, right? A, C, E divided by HCF of all the denominators. Please remember this. Whatever thing you want to find, whatever thing you want to find, that must be applicable to the numerator. This is the formula to find LCM of fractions. Similarly, if somebody asks you, or the question is related to the formula for finding HCF of the same A by B, C by D, E by F, in that case, take the HCF of all the numerators and divide them by the LCM of all the denominators, right? So this has to be the formula to find the way for HCF and LCM of fractions, right? So we will use this formula, the first one, as we have to find the LCM of these numbers, right? I hope it is clear. So what I'll do is, uh, I'll just eliminate everything. So this is 2.5. I can write 25 by 10. This is 5 by 10. And this is 175 by 1000. As there are three, uh, after three digits, I have a decimal, right? So finding the LCM of this, we know the rule. Find the LCM of the above numbers, 25, 5, and 175, divided by HCF of 10, 10, and 1000. Now, what is the LCM? You see, all these numbers are multiples of 5. So 5 also is there, 25 is also here. So 175 ones are 175. 5 cancel this, yes. 25 also cancel it 7 times, yes. So what is my LCM? 175. And what is the HCF? HCF is, you can see 10 is there, 10 is there, and 1000 is there. So we can see that the HCF is 10, because 10 is present in all. Like 1000, I can write 10 into 100. And in the other cases, we have 10. So what is the highest common factor? 10, 10 everywhere. So what is my answer? 17.5. Option D is my answer, right? Okay. Let's come to the next question, where you asked about the HCF of this power, 3 to the power 125 minus 1 and 3 to the power 35 minus 1. So if you just observe 3 125 minus 1 and 3 to the power 35 minus 1, right? This is the question that we have to find the HCF of. Now what happens? This minus 1 is common. So what we do, we take the HCF of these powers, and that is our answer. So what is the HCF of 35 and 125? So you can see 20, 35 and 125. They only cancel by 5. 5 is the highest common factor because this can be written as 5 into 7. This can be written as 5 into 25. So 5 is the highest common factor. So what is my answer? 3 to the power 5 minus 1. Right? So what is the rule? The rule is whenever you have been asked about the HCF of powers, like HCF of some number to the power m minus 1, right? Another the same base to the power n minus 1. Then remember the rule for HCF. What we do? We take we take the LCM of both these powers minus 1. This is going to be my answer. HCF LCM of mn minus 1, right? So what is my answer? Option number 2, right? Okay. Next question. A forester wants to plant 44 apple trees, 66 banana trees, uh, 110 mango trees in equal rows. Now, please highlight this word equal. Please highlight just to understand it properly. Yeah, because from here you will learn the next concept in equal rows. That is right, equal rows in terms of number of trees. Also, he wants to make distinct rows of trees. So, how many rows he can make? The minimum you have to find. Okay. So, what is the data? The data is that you have 44 apple trees, you have 66 banana trees from here, right? And 110 mango trees. So, and now you have to make equal rows of all the trees. You see, what is the meaning of equal rows? Equal rows means that like there are 44 apple trees, 66 banana trees, and 110 mango trees. Equal rows means that what you will do is you will just try to place the maximum number in one row. Yeah, you can say like this. Like 1, 2, 3, 4, 5, 6, 7 row. This is a row, right? Row 1, row 2, like this. So how many trees will come in this first row, and the same number has to come in this much. So you have to make equal rows actually, equal rows like whatever equal rows in terms of number of trees means here the number of trees should be same. Like suppose I say so tell me what is the least number which is divisible here. Like what is the least number or the maximum number which is factor of all. Suppose I take 2. So yes, I can take 2 also. So if I take 2 rows here, 2 trees here, then 2 trees here, then 2 trees here, right? Like this. So is it any number which is more than 2? So if you factorize it, you will get. So basically, guys, in this type of question, when we have to find the equal number of trees and then we have to find the number of rows, in that case, we always find HCF. Why? Because HCF is the only number which is the highest common factor of all the three. And that number rows we can place here. Like that many trees we can place here. I hope you're getting my point. The question is this, that you have three different type of trees, but now you have to make some rows, and in every row there should be maximum number of trees and they should be equal in every row, right? Like this. So the maximum number of tree will be that maximum number which is available here, right? So what is the HCF? You can see 6 into 11, 11 into 10. You can see the HCF of this all is 11. This is my HCF. Are you getting? 11 is present everywhere. You can see. So the highest common factor is 11. That means in one row, you can have 11 trees like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then again 11, again 11. So first question we have got that if you want to find equal rows in terms of number of trees, so the maximum number of trees in one row, that is how much? They must be 11. Now you have to find the number of rows, how many rows we can make. So just say how many apples are there. Apple trees are there 44. So total 44 apple trees, and in one I can have maximum 11 trees, so there will be four rows of apple trees. Can I say 11 fours of 44? Yes. After that 66, I have 66 banana trees. Now maximum in one row I can have 11 banana trees. So there will be six rows for banana trees. Similarly, 1 1 10 for mango. So in one row maximum 11 mango tree can come. So how many rows for mango trees? 10. So what is my answer? 4 plus 6. Mm. Acha, sorry. This LCM is HCF is not 11. It is 22. Why so? Because 4 is here, 6 is here, and 10 is here, so 2 also is common. See, what I'll do is 44, 66, and 110. So one way we have tried to factorize it, like 4 into 11, 6 into 11, and 11 into 10. But you can see that in 4 we have 2 also, 2 square. In this we have 2 into 3 into 11. In this we have 2 into 5 into 11. So which number is present in all? You can see that 2 into 11 is present in all. Here also I can write it 2 into 2 into 11, as 2 square can be written like this. So 2 into 11, that means 22 is my HCF, guys. Right? And another way to find the HCF is, we have discussed in yesterday's class also, that take the difference of A and B, then B and C, and C minus A. So what is the difference here? 22. What is the difference here? 44. What is the difference here? 66. So what is the HCF of 22, 44, and 66? That is 22 only, because 22 ones are 22 twos are, and 22 threes are, right? So this is the HCF. That means 22 is the HCF in both cases. You can see the best method is take the difference of B minus A, then C minus B, and A minus C, है ना? Whatever is the HCF of all the differences, that should be the answer. Now you see that this 22 cancels all. That's why this is the HCF. If 22 does not cancel these differences, then 1, 2, 3, we could have checked for the HCF. Fine. So difference HCF of the differences, if that difference cancels everything, or the HCF cancel the differences, like 22 cancel everything, so 22 is the HCF. Now 22 is the difference. So how many rows of apple trees? 44 by 22. How many rows of this banana trees? And how many rows of mango trees? So we can find it now very easily. 5, 3, and 2. So what is my answer? Answer is 10. Right? So good question again. Now come to the next question. It says the greatest remainder which divides all these numbers, which divide this, and this, leaving the same remainder in each case. So remainder should be same. So please write the way how we solve this question. Again, we have to find the HCF. The same trick is applicable over here. Whenever this same remainder question comes, always find the difference. What is the difference of B minus A? Then what is the difference of B minus C? And what is the difference of A minus C? So this is 6, 4, and 2, 246. Then find the HCF. What is the HCF of 123, 123, and 246? So you can see 123, 123, and 246. The HCF should be 123 only, because 123 twos are is only 246. So 123 is present in everywhere. But the important point is when you see the options like this, or even you see the options also, options are small. And if you try to divide this 4003 by 123 or 4126 by 123, it won't cancel. If it does not cancel, that means there is something wrong. That means this could not be the HCF. So we have to split this now. So this can be divided by 3. So 3 into 41. Now 41 is there in the option. So just check whether this number is divisible by 41. Right. Now this is 41. Anyone you can check. 41 nines are 369. So 1 and 3. 3, 1, 3. Yes. I'm left with 31, I guess. Yes. Now I need to have 3. So 4003. So just divide 4 sevens are 28. I say 7 1 is 7, 2 8. 41 8 are 8 1 are 8. It's 328. So this is more. So what is the difference? 6 and 13 7 6, and this is 26. So 26 is the difference. 13 13. Yes. Now if you divide the same number 41 by 4126 by 41, again 41 ones are 41, 26 is the remainder. You can see the remainder is same. Even if you divide this also by 41, 149 will be there. Now 41, you can say 4s are, no, 3s are, 3 ones are 3. So 123. Again, the remainder is 26. So you can see when I'm dividing these numbers by this 41, I'm getting the same remainder every time. That's my answer, 41, right? So 41 is my answer. So find the HCF, then find the HCF of differences. After differences, just check also that that number should must divide all the three given numbers. If it does not divide, factorize that number and then again check. Okay, so this is the concept. Next one, least number of 5 digits which is divisible by this and remainder is this. So whenever we have yesterday learned it that whenever you have to find this number divisible by, always find the LCM. So first find the LCM, then it's a same difference. Just see, it is 40 divisible by 40, difference is remainder is 31. Divisible by 60, difference is 51. Divisible by 75, difference is 66. You can observe something that it's a least number, divisible by so LCM, and they are all having a difference which is 9. So in this type of question we have yesterday discussed that LCM minus divisor minus remainder has to be the answer. So yeah, this is my answer. So let's find the LCM of all the numbers. So 40, 60, 75. 40 is 8 into 5. 60 is 15 into 5. 3 into 5. 15 into 4. 4 is 2 to the power 2. Right. 75 is 15 fives. So 3 into 5 into 5. So I can write it as 5 square. And to find the LCM, I know what I need to do. I need to find the highest power of every number. So what is the highest power of 2? That is 3. Highest power of 3? That is 3. Highest power of 5? That is 2. So this is my LCM. Now this is 8. 8 3s are 24. 24 into 25. So 25 4s are 100. 25 2s are 50. So the LCM is 600. 50 plus 10. 600 is the LCM. Now, there is something important. If this 5 digit is not written, then my answer could be 600 minus 9, which is the difference of divisor n. So in that case, my answer would be 600 minus 9. I would say 591 is my least number. But here, 5 digits is also written. That means I need to check it further now. I need to check this, whether this is verified by 5 digits as well. So now I'll rub all of this. I know that I have got 600 as the LCM. So divide this 600 by the least number of 5 digits. And what is that? It is 1 2 3 4 5. It's 10,000. Just divide it and just solve it. What is the remainder? This is 400 and then 0. 6 6 are 36, I can say. So 400 is my remainder. What is my remainder? 400. Now we have discussed this in the number system as well, that when we have to find the least number of digits number, then because if we subtract this 400 directly, then this will be 9960, right? Which is not a 5-digit number, right? So you can subtract it, like if you subtract this, obviously the remainder will be 0, and after that you just have to add 600 to get the next multiple. So if you add 600, then 10560 has to be the, see, if you subtract 400, this will be 10,000, right? So 9,000, sorry, not 960, it's 40 I subtracted. So 400 I need to subtract. So this has to be how much? 9600, guys. So 9600 is completely divisible by 600, but I have to, because it's a 4-digit number, I have to find the next. So what is the next multiple? If I add 600, like if I want to find the next multiple of 8 after 2, I will add 2, है ना? This is the logic. So if I want to find the next multiple of 600 after 9600, I have to add 9600. So if you add, you will get this 0, 0, 2, and n. So this is our number. But remember, we have this difference also in mind. This difference was 9. So this 9 difference I will subtract, and my answer is option C. So this is one way. Or after finding this division, I have told you the shorter way, that always take the difference of these divisor and the remainder. So what is the difference? 200. So add 200 in this. So 10,200 will directly come, and subtract this 9 from this. Why 9? Because that was a difference of divisor and the remainder. So my answer is 10191. I hope the concept is clear. Next is again 476 boys and in a school divided into, again focus on the words, divided into equal sections, divided into equal sections, and either boys or girls, okay, alone. That means it's again the same row type. So you can see options, like question number are big and options number are smaller, so we have to find HCF. And the other way is, like, we have to select boys or girls into equal sections. That means that the number which divides both of them, that can, in that only we can divide them in the equal section. So what is the HCF of 576 and 448? I have told you the best way to find HCF is find the difference. Now, how much difference is there? Uh, it is 128. 128. But if you cancel this by 128, it will not divide. But if you break this into 64, this is cancelled by this 64, cancel both. So we can say that 64 is the HCF. That means 64 people, 64, either you keep boys, right? Like in one section, 64 people should be there, maybe boys or maybe girls. But now the next question is, how many number of sections you can form? So again, the same type. So if there are total 448 boys, sorry, girls, and I have in one row there is 64 girls, how many rows we can make? Divided. Or 576 also, if I want to find number of rows in one row, 64 boys are there, total this many boys, so we can divide it. So 4 4 is 8, it is 64, 8 5s are 40, and 8 6 are 48. So this is 7, this is 8 8 is 64, 8 7 is 56, it's 9. So 7 plus 9, answer is 60, right? Next, the square of a number greater than 1000, which is not divisible by 3. So for this, you can take any number which is greater than 1000. So I know that there is a square, perfect square of 32, because 31 is 961, it is less than 1000. If you see, this number is not divisible by 3. You can see that 4 plus 2, 6 plus 1. So 1 is left. If you divide this by 3, the remainder will be 1. If you take the next number 33 square, so that is 1089, but it is cancelled by 3. So we'll not take this. It's because it's already mentioned it should not be divisible by 3. So I'll take 34 just for verification. So it is 1156. So 6 plus 5, 11 plus 1, 12. Even if you divide this number by 3, remainder will be 1. So please remember, for this type of question, the answer is always 1, even if you take any number of squares after 1000, right? So let's move on to the next. It says HCF and LCM of this. So we know the way: 2 to the power 4, 8 to the power square, 16 to the power 2, and 20 to the power 3. First, break them into their respective prime factors. So 8 can be written as 2 to the power 3, and 3 into 2 is 2 to the power 6. 16 is 2 to the power 4 into 2, 2 to the power 8. 20 is 5 into 4, which is 2 square into 3, and 4 into 5, 5, 3, right? So this is, we can write 2 to the power 6 into 5 to the power 3. Now we can just check it. What is the HCF? For HCF, the highest power of 2 I have to take. So, sorry, the lowest power for HCF, I have to pick up the lowest power, right? For LCM, I have to pick up the highest power because it's a multiple, it's a big number. So what is the lowest power which is present everywhere? The 2 is present everywhere first, 5 is not present everywhere, and 2 to the power 4 is the lowest power. So HCF should be this. So this option is rejected. This option is also rejected. Now for LCM, take the highest power of all. So highest power of 2 is 2 to the power 8. Highest power of 5 is 5 to the power 3. So 2 to the power is 256, and this is 125. 125 6, if you solve, you will get 32,000, and that is going to be my answer, right? So again, a good question. Next, the 4-digit smallest positive number divisible by this leaves the remainder this. So in this type, again, divided by, that means we are looking for this multiple. So find the LCM, and this is a special type where the remainder is same. That is only 3. It's the remainder is same, not the different remainders. So in this case, the answer should be LCM plus the same remainder. Please note this, very important type. Okay, so what is the LCM of 4, 5, 6, and 7? So 4 is 2 square, 5 is a prime number, 6 is 2 into 3, and 7. So if you see, the highest power of 2 is 2, then 3, then 5, then 7. So it should be 4 3s are 12, 5s are 60, 7s are 420. So 420 is my LCM, and what is the same remainder? Acha, if you see, this is 423, which is not in option. Now what to do? That means 423 will not cancel this, right? Or you can say 423. Why this is not the answer? Because read the question very carefully. Another point, it says it you have to find the 4-digit smallest number, 4-digit number, and 423 is not a 4-digit number. Now come to the basic concept of division. What is the basic concept of division? That is, after we have found 420 and this 3, what we'll do is, the basic concept says that uh, this number is 423. This number I need to find. I don't know the question, but the remainder is this. So every time uh, this number will be in this form, na, divisor into quotient plus remainder, because this is called dividend. Dividend is divisor into quotient plus remainder. So 423q plus 3. This is my number, and if I put 1 here, so it's sorry, it's 420. 420 was the LCM, right? So 420 into q plus 3. Dividend we have to find, and this will be in this form. Now just put the values. If I put 1, I will get 423. 420 into 1 plus 3, which is a 3-digit number. I need to have 4-digit. So let's put q as 2. So that will be 420 into 2 plus 3. That is 843. Again a 3-digit number. Go ahead. Put Q as 3. 420 into 3 plus 3. This, I guess, we will get the 4-digit number. So this is 1263. That's why my answer is option C. Okay. So don't only look for the, yesterday we have discussed this LCM plus common remainder, but here the number has to be 4-digit. That's why we have to go one step ahead. Okay. Last question. LCM of two numbers is this 1020, and their HCF is 34. Possible pair of numbers. We know that the numbers will be in this form, 34A and 34B. And I know that HCF and LCM of two numbers is equal to their product. So LCM into HCF. Yesterday, in this class only we have discussed, even yesterday we have discussed that product of two numbers will always be equal to their HCF and LCM. So I am applying this. 34 gets cancelled. 34 threes, I guess. So I am getting the product of two number as 30. Now I need to find a suitable pair, possible pair. So 30 has to be broken into two co-primes. So the first value will be 1 and 30. Second will be 2 and 15. Next, it could be 6 and 5. Right? I hope there are three possible values. Rest we can't have 5, 6, 6, 5. Yeah. 10 into 3. Yes, another is 10 into 3 also is co-prime. Any other? I guess these are the only possible. Now, out of these, one value is possible. Let's find. So if you find 1 and 30, the first number is 30, because 34A and 34B are my number. So the first number has to be multiple of 34. So 34 into 1 and 34 into 30. So 34 and some other, but 34 is not present. And this is 1020. So this is not present. I will not take this. 34 into 2 is 68, and 34 into 15. What is 34 into 15? 15 fours are 60, 45. So it is 510. This is also not present. I will not take this. 34 into 6. 6 fours are 24. So 204. Yes, this is present. And 34 fives are 34 fives are 30 into 5, 150. So this is 170. Yes, this is present. This is present here. So I can take this as the answer. There is no need to check this because already I've got the one number, but just for clarity, you can check 34 into 10, 340. 34 into 3 is 102. So 102 and 340 are also not present. Already we have got the number. So this is my answer. Right. So that's all for this session. I hope you have learned something in this session. Thank you so very much for watching.